Hello everybody, in this episode I'm going to make this very nice letter on a block of wood. From making the 3D model to generating the G-code for milling on the CNC, I will explain everything so you can make it easily. There are a lot of struggles that a new FreeCAD user has, and I try to cover most of them here along this video, and you might find them useful for a lot of different other projects, not just for this one. So let's start making this block of wood with a letter on it. Whatever it might be used for, it's a very nice project. It seems kind of easy, but there will be some tricks on the way, which I'll show you to make everything faster and better. So let's get started. First of all, let's move to the part design workbench, create a new body, create a new sketch. Let's place it on the XY plane, and let's create a rectangle. The piece of wood that I'm going to use is 150 millimeters by 70 millimeters wide. Click close to close the sketch, go back to the model, select the sketch and click on pad button. And the piece of wood is 25 millimeters thick, but I will only pad this part 20 millimeters because for the next 5 millimeters I will pad the letter. Let's go to the draft workbench. Select the shape from text button. Let's say I want to write the letter R, give it a height of around 90. This can be changed later, and let's select a font file. I will select this one, click on OK, and you can see the letter is randomly placed in this plane, the plane that was automatically created when moved to draft workbench, but I want to place it on the face of this body that we just created. First of all, I will press G and R to hide this annoying grid. Select the shape string, go to the map mode in the data tab, and where it says deactivated, press on the 3 dots. Make sure selecting is pressed, it's blue, and select the face of the body. Now click OK. It looks kind of close to what we want. We still need it rotated, so I will go to the shape string, go to the attachment offset, open the axis, make sure there's 1 next to the Z axis. I will write here -90. Under the attachment offset, close the axis, open the position, change the Y to 45. I think it's a little too small. I will write here 80. Now it's a little bit too much, but I can already see that the letter is too high for our block of wood. Select the shape string, double click on it and change the height to 70. Click on OK. Now it is reduced in size. We can change back the Y, reduce it to 60. I think 65 should do it. Okay, and now we still need to center it on the x-axis in this situation, so I will give it a value of 40. Let's set a top view. It looks as it should. Now let's hide this body and take a look at the shape string. You can see it is pretty messed up, so still in the draft workbench I will click this button, which is downgrade, and it changed the shape string to several wires. This little square, which we don't need, so we can delete, and the final one, this part of the R, we can see here it misses a little segment, so let's hide the other two. Select them in the tree and press space. Surprise, that part actually was there, it was just not visible. Let's move to the part workbench. Select this wire, press this button, make face from wires. Turn the visibility for the second one, and if I press this button now, make face from wires, you will see a problem. There's no hole here for the R. I will undo this. Turn the visibility for the first wire, select them both, and now I will press this button, make face from wires. I still have these overlapping pieces here, but the face is now correctly generated. For this union of faces, there's no tool available in this menu. I made a macro, you can download it on my Patreon page. Go there, you can download it for free. Of course, you can subscribe and it would help me a lot to continue what I do. You can find a lot of other resources, such as the final version of this file with a letter. So let's go to the macros, select the join faces macro, click on execute, and now if I hide all these 3 wires, you can see a single shape, which is the correct shape of the letter R with all those intersections and overlapping lines removed. So I can now delete all these wires, I don't need them anymore, and I have the body and the shape sitting on top of it. Still in the part workbench, select the shape and click on extrude. I will extrude it for 5 millimeters. Don't hit apply and OK. Let me show you what happens when I hit apply and then OK. I have 2 extrusions, one over the other. I will undo this. I will select the shape again, click on extrude, write the 5 millimeters and then simply click OK. You can see now that the letter is embossed as it should be, but I still can't move to the CAM workbench because they are separate pieces. You can see here, if I select the body, only the bottom part is selected. If I select the shape, only the R letter is selected. So I will select them both and make a Boolean operation, a union between the two solids. click on apply, close it, and now I have a fusion between these two parts, a single object. I want this little part of the R to be a little recessed. If I select it here and press the extrude button and let's give it a -5, it will give me an error. So let's select the fusion, move to the part design workbench and create a clone. I will turn off the visibility by pressing space for the fusion, and the new body that has been created, I will call it, press F2 to rename it, final shape. This is the final shape that we are going to mill. Almost final. Make sure the visibility of the fusion is turned off, because otherwise when I select this face and I want to make a hole with it, it might select the face from the fusion, not from the final shape. Right click and click on active body. You can see it now bold, so it is the active body. Click somewhere else to unselect everything, and now I will select this face and use the pocket button, make a 5mm pocket. And now this part of my letter is lower than the outer part. So now we have the final shape ready. Let's move to the CAM workbench, to the path workbench, depending on the version. As you know, until 0.21 the workbench that generates G-code was called path workbench. From 0.22 on the workbench will be called CAM. So now that we are in the CAM workbench, I will select the final shape and click this button, which is create a new job. Make sure it has this final shape checked and click OK. And we are by default in the setup tab. Here I can set up the stock, which I'm setting it to extend models bounding box. It automatically generates a bounding box for the model. It extends it with the values that I write here. I will extend it with 3mm, which is half the diameter of the tool bit that I'm using. I'm going to use a 6mm end mill. I will extend it on both ends of the X with 3mm and on both ends of the Y axis with 3mm. I do this because I want to be able to force the cutter to stay within the stock to avoid hitting other parts of my CNC, but to have enough room to run along the sides so it doesn't leave any material behind. Now let's move to the tools tab. I have a default tool with no values, so I need to add a new tool. I will add the 6mm end mill. If you don't know how to create a certain end mill, go to my channel. You will find there a video about creating end mills based on existing tool shapes, and another video to create a custom tool shape and create a new end mill using that custom tool shape. Now let's give it horizontal and vertical speeds. I will use 3000. It's a value that fits my machine correctly when I'm using this 6mm end mill on hardwood. The vertical speed will be the same, and the corresponding speed on my machine is 18,500 RPM. And now after pressing tab and moving to the default tool, I can click on the remove button. I will add a second tool, a 60° V-bit. I want to use that to bevel these edges, to chamfer these edges, and I will give this tool a 2000 horizontal and vertical speed and the same spindle of 1800-500 RPM. Now I have both the tools that I need. Go to the output tab, make sure the processor is set correctly to the one that you are using. In my case it's GRBL. I'm using a fluid NC controller, which is an extension of the base GRBL. The output file can be entered now, or I can enter a name whenever I click the post-process button in the CAM workbench. And I want to modify something else. I want to go to the order by and change it from fixture to tool and check the split output button. What does this do? For each tool it will generate a separate file. This helps me because I don't have an automatical tool changer, an ATC, and this helps me by exporting the G-code in separate files. I can load one file, run it on my machine, then change the tool, reset the Z of course, open the second file, run it, and so on, depending on how many tools I have set in the job. Of course, sometimes this works, sometimes it doesn't. Maybe I want the operations to be in a certain order and I prefer to change the tool several times. In that case, I will modify the order by tool to order by operation. This time I will do this because I want to cut everything, then to chamfer the edges. In the end, after making all the operations, I want to cut the outline. The outline will be cut with the same cutter that I'm going to make all these pockets. If I export them ordered by tool, it will include the profile filing in the first file, which is not a good thing. So I want them ordered by operation, which will generate one file for each operation, and it's safer this way. So now that I've set the export, I will go to the setup tab, and here in the bottom you can see default values. The step down is up tool diameter, which in my case will be 6 millimeters. I think it's way too much. I want tool diameter divided by 3. I want a step down of 2 millimeters. Two more things that I want to modify are the clearance and the safe height. Instead of the 5 and the 3 default offset, which of course you can modify in the preferences, I will use a clearance of 35 and a safe height of 33. I can now click OK to close the job. So let's get rid of these errors. They are probably because I'm using 0.22 development version. I will select this face and press the pocket shape button. Select the tool controller that I want for milling all this surface. Of course it's the end mill, not the V-bit. Click on apply, and now I can work on the pocket shape operation. The first thing that I want to do is change the pattern from zigzag to zigzag offset, because you can see here on the zigzag there will be a lot of little pieces left in the ends of the zigzag. Zigzag offset makes one final pass, which will leave a very clean final result. I will also change the angle from 45 to 0 because my machine is stiffer on the x-axis and I want most of the cutting to be done by movement on the x-axis. Of course, depending on the machine, you might want to use movement on the y-axis, in which case you must change the angle to 90 and most of the cutting will be done on this direction. I will change the step over percent to 70 because I want the lines to be a little overlapped. And let's take a look at the G-code that will be generated. I can see here some little problems. The cutter won't get outside of this face, which means it doesn't fit here between the edge of the R and the edge of the bottom. What I need to do is go to the extensions tab, check the enable extensions. I make sure that it is the correct extension. It is around the entire block of wood, so it's okay. I will check it, click on apply. I can close the operation, everything is okay. If I set a top view, you can see that the inside of the R hasn't been made. Why didn't I do that? If I open the pocket shape operation, I only have one final depth. It doesn't matter how many faces and at which height they are, the entire operation will be only run to a certain depth. If I set the height to the height of the inner face, the outer face will also be cut too deep. I need to create a new operation for this face, but I want all the settings to be the same, so I will select the pocket shape, click on this button, copy the operation in the job. It creates an identical copy of that pocket. I open it, go to the base geometry, remove the face that was from the initial operation. After selecting, click on the add button to add the inside face from the circle of the R. Click on apply, and now it automatically updated the final depth with the depth of this face. You can see it going all the way down. What I still want to do is to make a little bevel on these edges to make it smoother. So I will select this face, go here, select the deburr tool. If it's not already shown here, you have a little arrow, you have to press it. Sometimes the engrave, sometimes the V-carve is by default selected here, depending on which of the operations you last used. I will select the deburr operation. Make sure you change the tool controller from the 6mm end mill to the 60 degrees V-bit. Clicking on apply shows you the path that the deburr tool is going to follow, but I need to make some minor adjustments. I will close the operation, clicking OK. The V-bit that I've entered when creating the job is a 60 degrees V-bit, but my V-bit is a 90 degrees V-bit. Of course, the best way would be to go to the CAM, to the toolbit library editor, create the new tool, but let's say I'm in a hurry and just go to the job, to the tools tab, to the controller of the 60 degrees, and there I can find the actual toolbit. So I will double click on it, change the angle from 60 to 90, make sure all the other values are okay. I will also change the name. All these values that I'm changing now will only be modified in this document, so I won't affect the initial toolbit, and it's a very useful way to do things when you are in a hurry. Click OK after editing the toolbit. Also change the name of the controller because you need to know what you're working with. And now the deburr is pretty messed up. Let's open the operation and fix everything, because with the new values the width and the height are messing up everything here. First thing, I want a lower width. I want a width of 0.5 millimeters because at the ends of the letter it will simply cut the entire height. And to fix all this messing which happens because of these vertical lines, I have to modify the height. I will give it a value of 0.1 millimeters. Now everything works okay. As you have noticed, I haven't used the chamfer tool in the part design workbench because that generally messes up things. So when making models for the CNC, it's better to forget about chamfering, just add them later based on a straight line on the correct height. This will calculate correctly everything. If I had a line lower, I would have to change the height and everything would be messed up. I also want a chamfer on the outside. If I select the face and click on the deburr button, you can see I have some errors because it also tries to make the chamfer on these edges of this face, which it simply cannot. So I will have to go to the base geometry and remove the face, then manually select each of the lines and click on add. In this case there are only 4 lines. Sometimes it might take some time because there might be many lines if you have curves. Click on apply and now you can see everything is okay. It does the job correctly. I hope it does take into account the cutter bit not hitting this part of the R. I have some doubts, so let's make sure it doesn't cut this part. Let's modify the edge value. The height of the cutter bit was 10 millimeters, so I can use a value of 8. And now you can see the cutter bit will be much farther away from the stock. So now I can click OK, this operation is ready. Let's turn on the pockets. I still want to make the face of the R to flatten it perfectly. Let's hide all the other operations. Select the face, click on the millface button, and after clicking apply, of course, let's make some changes to make the facing operation okay, to have the entire top face of the R letter flat and nice. The first thing that I want to change is the pattern from zigzag to zigzag offset. Again, I want also the edges to be cut. Click on apply, you can see now a pass on all the 4 edges. Change the angle to 0 again to adapt to my machine, but it will still leave some unmilled material on the corners on the bottom line here. I will go to the material allowance field and write a value equal to the diameter of my cutter head, which is 6 millimeters. Make sure at the tool controller you have the correct tool bit selected. Click on apply, click on OK. Now let's enable all the other 4 operations that we have already created, and we still have to make one final operation, which is cutting the outside. Without anything selected, click on the profile button. Let's click on apply. Make sure again the tool controller is correctly selected. Usually when creating a new operation, the tool controller will be the one used in the previous operation that we have created. So whenever creating an operation with a different tool bit, make sure you don't forget to change it from here. I will click on OK and make one more thing. This piece of wood will be held down from a larger piece using screws or clamps. So I want to remain a little bit connected to the entire piece that I'm using. So I will select this operation, go to the cam or path menu depending on the version that you are using, go down to path dress up and select tag. By default creates 4 tags. I want them here and at the other end. So I just want 2 of them. I will select randomly 2 of the existing ones, click on delete, then select the first one, click on edit and scroll here, select the bottom line somewhere in the middle, click, and you can see the tag has moved here. It hasn't updated the G-code yet and I won't update it now. Scroll to the other piece, rotate the view, select the second tag. You can see here it's highlighted in a yellowish green and a little bit larger. Click again on the edit button, select the point. You have to be on one of the lines when selecting the point. I can now click the apply button to make sure I have correctly placed them. I want the angle to be a little steeper. I will use a value of 80. I can now close the dress up, the tag dress up. So now that I have all the operations, I can select the job and click on the job post-process button, which will export the G-code according to the processor that I have selected, to the parameters, to everything that I have selected. And it shows me a window with a G-code generated. It's the G-code for the first operation, so I'll click OK, the second operation, the third operation, the fourth, the fifth and the 6th operation. And now I have to save the files for each of them. R letter part1.nc. You have to enter the extension, otherwise it will throw an error. Click on save, go back to the same folder, save it again, go back to the same folder. It's kind of annoying, it defaults to the folder of the, you can see here I have a weekly build in the bin where the FreeCAD.exe was run. That's the folder where it defaults, so I have to change the folder for each file. If I had set a name and a location for the file when setting up the job, all the files would have defaulted in the correct folder, so you'd better go to the job, change the file by default. I will do that now so you can see how to save some time when saving the files. Double click on the job, press on the three dots, select the folder and right here milling the R letter.mc. Click on OK. Now select the job again, click again on the post-process button, click OK to the G-code. You can inspect it. Sometimes you might find some errors here. Go back, modify them and export it again. And now you can see it defaults to the correct folder. I don't have to keep on changing the folder. It takes the name that I have set there and after that it writes the name of the operation. So you might take into consideration renaming all of the operations before exporting them. It will be much easier when using the files in the G-code sender. Click on save for each of the files. Now I will switch to the universal G-code sender, go to my CNC, and here it is what it turned out after a little finishing, a little distressing. Don't forget to visit my Patreon page to download the very useful join faces macro that you can find there and download it for free. Of course, you can subscribe. If you subscribe, you can also download this file so you can study it in more detail how the operations are made. That's it for this episode. Thank you for watching and see you next time.